Good morning. So, this is Dr. Maheswara Rao, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So, our course name is Fluid Mechanics, and the topic is Bulk Modulus of Elasticity. The course outcomes are, at the end of this course, the students should be able to define the fluids and their properties, and also they can describe the surface tension. And course outcome 2 is the Newton's law of viscosity. That means the classification of fluids based on the Newton's law of viscosity, and also related problems to the Newton's law of viscosity. So they will know that students after completion of this course, which will come under the course outcome 2. And course outcome 3 is the capillarity rise or fall. So if you put a small diameter tube in any fluid, a liquid rises or liquid drops in the small tube. So it is called capillary rise or fall. So that will be course outcome 3. And course outcome 4 is the surface tension and their applications. And the capillarity and compressibility as the course outcome 5, and the course outcome 6 is the pipe flow. That means whenever a fluid is allowed to flow in a pipe under pressure, okay, so after traveling certain distance, it will lose some of its energy. So, and there will be frictional losses in the pipe flow. So that will come under the course outcome 6. So today's topic is the bulk modulus of elasticity. Initially, what is the bulk modulus of elasticity? So you can see that here a definition. So it is denoted by maybe K, and it is nothing but the measure of substance resistance to compression. So if you try to apply a force, external force, so can it be reduce volume? Okay. So how much force you are giving and how much volume is reduced. So that is called here bulk modulus. In other words, it is nothing but the ratio. Okay. So ratio of pressure related to the volume. So change in volume. That means here volumetric strain. Change of pressure. Okay. This is the increase in pressure related to a decrease in volume. So if you increase the pressure, volume will be decreased. That means if a liquid is there, you are applying some forces. Okay. So then it will reduce its volume. Okay. So how much pressure is applied and how much volume is decreased. That is nothing but the here bulk modulus of elasticity. So here key concepts is the compressibility. See, nothing but the inverse of the bulk modulus. So 1 by K. So here compressibility is nothing but the inverse of this bulk modulus. Okay. So a material with a high bulk modulus, here compressibility. So here two words are there. High bulk modulus. So more bulk modulus and the less compressibility. Okay. So then isotropic compression. So involves uniform pressure application in all directions, leading a decrease in volume. Isotropic means in all the directions. So in all the 360 degrees. Okay. So that is called isotropic here. So you apply pressure in all the directions, then how much volume is decreased. You can see the figure here. So it is a cylinder, tube. Okay, some liquid is there. So if you apply a force, so on volume of V here. So volume of liquid is V here. The pressure is, the force is the F. So here the pressure or stress is equal to load upon area. Okay, here load, you know that area is nothing but the surface area of this liquid. So whenever you increase the force, so this is delta F is the increase in force. So then what will happen? This volume is decreased. This much volume is decreased. So that inside pressure, it will be P before increasing the force. So after applying a force, so pressure will be increased. So P plus delta P. So what will happen to volume? So volume will be reduced. You can see this much volume is reduced here. So this is the delta V. So change in volume with respect to the change in pressure. So if more pressure is changed, more force is increased and more volume will be decreased. So you can also see here bulk modulus is nothing but the degree of compressibility of a liquid. So if you see a balloon here, so air-filled balloon. Okay, air-filled balloon. So here, what is the atmospheric pressure? Okay. So here total atmospheric pressure. So inside of the bubble also some pressure will be there. Outside external pressure also will be here. So it is nothing but the air. Air means here nothing but atmospheric pressure. So whenever you are trying to keep inside this liquid, so what will happen? The force will be applied by means of this liquid onto the bubble. So you can see here, so outside of this liquid, so because air is present, so there will be pressure onto the bubble, okay, balloon, so which is the atmospheric pressure. So if you keep that same balloon inside this water, okay, so there will be water pressure in it. And whatever the force is exerted by the water, the same force will be exerted from inside, so that the balloon will be in stable condition. Here you can observe that. So here the volume is not decreased, here volume is decreased. So if you bring deeper and deeper into the water, so what will happen? At the top portion there will be less pressure due to this water column. This is much. So if you go below than this, so this much water head, that means that much force will be applied onto the balloon. So here the bulk modulus is nothing but the internal pressure and external pressure are the same. Okay. So beyond that, if we increase external pressure more and more by keeping deeper into the water, what will happen? The volume will be reduced. Okay. Whenever the internal pressure and external pressure equals, which is called bulk modulus, whenever you increase beyond that force, if you again increase the load, so internal forces cannot be created. Resistance cannot be created. Hence, the volume is decreased from this much to this much. So here it is the volume. Here the delta V is the change in volume. You can see here bulk modulus is equal to stress by strain here. Normally modulus is equal to any modulus is equal to stress upon strain. Here it is a bulk modulus. Bulk means it is nothing but a volumetric strain. So stress divided by volumetric strain, you can get the bulk modulus. So bulk modulus is nothing but the stress upon volumetric strain here. So volumetric strain is what? Change in volume by original volume. So that is called volumetric strain. Okay. So if you divide this change in stress divided by the change in strain, that means stress upon the volumetric strain, you will get the bulk modulus of elasticity. So you can see this figure. This jar is containing a liquid and force is applied here. In another jar, there you have got put the gas and we are applying the load here. Okay. So here what will happen? The molecules, intermolecular distance in the liquid is less. Hence, for a given load, there will not be any change in the volume. So if there is no change in the volume, that's why the liquids are normally called as incompressible liquids. But whereas air, the distance between the intermolecular force, intermolecular distance of the particles or molecules is more compared to the liquid. Hence, if you apply a load, so the volume will be decreased here. Here you can see stress is nothing but the load upon area. So practical applications. So fluid mechanics. So bulk modulus is used to describe the compressibility. So main purpose is that compressibility of fluids. So where it will be utilized, where it will be applicable means to understand the sound propagation in the liquids. So how the sound is propagating through the liquid can be known by means of this bulk modulus. And also you can see here material science. So materials under high pressure conditions. So how the materials behave. So that means if you go deeper and deeper into the sea or ocean, so what will happen? Up to certain distance, 130 meters, normal persons can go into that much deep into the ocean. So, but whereas beyond this, even 300 meters, so it will be high pressure will be applied onto the human being. That's why normal persons cannot go to that much of height. But if you see the submarines, all those things, they will travel well below that depth. So that's why, if you know this bulk modulus, the practical application is that how this material will behave under higher pressure conditions in deep sea environments or industrial purposes. So engineering considerations, where this will be utilized in engineering. So what is that? First one is the pipeline design. So here, how this bulk modulus will have effect on the pressure surges. That means water hammer effect in the pipelines. So if the huge pressure surges are there, water hammer effect is there, pipes will damage. So that's why, so you have to estimate, or have to know for the design of this pipeline, how this bulk modulus will affect the pipe material. And also hydraulic systems. So any fluids with low compressibility. So with low compressibility means what? High bulk modulus. So which one is prepared here? High bulk modulus or low bulk modulus? So low bulk modulus are not preferred because they are more compressible. So here high bulk modulus liquids are preferred for the efficient power transmission. So here today we'll learn. So what is bulk modulus definition? It is nothing but the substance resistance to compression, or it is the ratio of the pressure, increase in pressure to the decrease in volume. That is the bulk modulus. And key concepts are the compressibility is the inverse of this bulk modulus. So that means higher bulk modulus will give the less compressible. That means it is incompressible. And force, if you see this, stress is nothing but the load upon area. So whenever you apply a load on a volume of V of the liquid, so you can see this here. If you increase the force onto the liquid volume, what will happen? This volume is decreased. So volume is decreasing, delta V, and pressure is increasing because we are increasing the force, pressure is increasing, delta P here. So if pressure is increased, volume is decreased. So this much is the delta V. And here in this, a balloon filled with air in the atmosphere, so it will have atmospheric pressure. before entering into the liquid. So whenever we are trying to keep that balloon below the water level, so what will happen? Water pressure will be applied onto the balloon here. So if you take that balloon deeper and deeper into the water, so the volume will be decreased here. So here internal pressure here, and this is the external pressure due to water. So internal pressure and external pressure, if they same, then there will not be any volume change, which is called a bulk modulus. But whereas if still further increase of the force as you taking that balloon deeper and deeper into the water, because of the water column, more pressure will be exerted on the balloon. So internal pressure cannot be increased. That's why volume will be decreased here. So what is the meaning of volume decrease? Means the mass is same, volume is reduced. That means density will be increased here. So you can see internal pressure, external pressure, and change in volume. So bulk modulus is the stress divided by volumetric strain here. So volumetric strain means change in the volume divided by original volume. So bulk modulus is equal to stress divided by volumetric strain, whereas volumetric strain is nothing but the change in volume by original volume. You can see this. And if you take a beaker, if you apply a load, one beaker is with liquid, another beaker is with gas. So the liquid will not reduce its volume, but whereas the gases will reduce its volume, because the intermolecular distance is less in the liquids, whereas the intermolecular distance is more in the gas. Hence, the volume is reduced by applying some force onto the material, gas. If you see the practical applications, so bulk modulus is used to describe the compressibility of fluids. How these fluids are compressible. So that will be described by this bulk modulus here. So how it will be utilized means you can know the sound propagation in the liquid here. So in the liquids, how this sound will be propagated based upon the this compressibility or bulk modulus. So how much bulk modulus is there, how the sound will be propagated in the materials we can understand. And also if you go deeper and deeper and see environments, so how this material will behave under the high pressure conditions. As we go deeper and deeper, like submarines, they will travel well below the deeper levels. So hence there will be at higher pressure conditions. Okay. So then how this material will be acted upon by this liquid. So if you see the engineering considerations, if you want to design a pipeline, so you have to know this bulk modulus of that particular liquid. So there will be a pressure surges will be there. That means water hammer effect. Okay, because of the water hammer effect, the pipeline will be damaged. So that we have to know the quality or quantity or thickness of the pipe material. So in order to safeguard that because of the water hammer effect. And hydraulic systems, if you best efficient power transmission you want, then you have to use the high bulk modulus liquids. So high bulk modulus liquids if you utilize, then the power transmission will be more efficient. So references are Subramaniam, okay, Theory and Applications of Fluid Mechanics, Tata McGraw Hill 2012, and Modi and PN and SMC, Hydraulics and Fluid Mechanics, Standard Book House 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.